Dr. Chuck the Science Schmuck.
Synchronize. So, this thing is my alarm clock. Now that may seem totally normal, because it is totally normal. This is definitely an alarm clock. This is definitely what an alarm clock's supposed to look like. That's definitely how they're assembled. Definitely. Why? It's a question I ask myself every single day with every single action I perform, because I can never answer it. But in this case, the why is, why did you build it like that? The answer is, well, I actually have a theory. And not a scientific theory, because scientific theory is a body of evidence, or a body of material well supported by evidence. This is a layman's theory, meaning an unsubsorted, it's an unsubsorted hypothesis. Basically, when common people who are not scientists say subsorted, I mean subsorted. That is a clock. My idea for how it works actually works well in one way, but not in another way, which we can get to. But sound. Sound hurts. I don't like being yelled at. Except I do like being yelled at. In the comments, please. I can hear them. I can hear you ticking away. You know, I had coffee around here, but I don't know where it went. I think I drank it. I'm not getting that coffee back. The point of this device is light. Now, human beings, when they're asleep, usually have the capacity to wake up. If you cannot wake up when you are asleep, it is a very unusual sleep, and you are either in a coma, or dead, or a very heavy sleeper, or a combination of the four. Usually, though, there are two mechanisms by which human beings wake up. Because the human brain, when you're asleep, isn't off. It's still running, it's still there, it's still metabolically active, it's just active in a different way. It's not like flipping a switch and it turns off. It senses everything. Your brain is still listening to the world because that's how life works. If you're a caveman sleeping in a tree and a tiger comes up and starts making tiger sounds, your brain goes, oh no, a tiger. Likewise, if somebody shines a light in your eyes, them aliens coming to get you, you wake up and run away. Because aliens can't run very fast. They got them spindly little alien legs. Except that one type of alien that's got a lot of spindly legs. Those guys you can't outrun. I don't know what to do in that case. Hope the tiger's around. Because it'll eat you before the alien can get. A combination of a non sequitur and a side? Perhaps I drank too much of that coffee. Or had confused it with something that wasn't coffee. Sound, when I wake up, is very shocking to me. When a cell phone alarm goes off, an alarm clock alarm goes off, I don't like it. I don't like that sound. I freak out and panic, which does wake me up, but it also gives me the shakes. Because, when you get a sudden shock, you go, and then you can't move. So I don't like it when the alarm has sound. It's too strenuous. Because in a caveman sense, when you hear sound to wake up, that's a danger sign. And that's how you wake. It's a sudden surge of adrenaline. You just jump out of bed and you're like, ah! So I built this. It uses light. Because how does a human in prehistoric times wake up on a normal day? You're, in your caveman bed. I don't know, you're sleeping on rocks. Very comfortable. And the ancient sun comes gently arising through the trees full of tigers. You look at it, and you wake up, and there's the sunrise. Oh, it's time to wake up. Usually humans wake up when light is exposed to them. That's what this machine does. It is a lamp connected to a timer connected to a light bulb. With the idea being that I can set the timer to come on a certain time of day and the light turns on and wakes me up. And this is actually extremely effective, at least for me. I don't know for other people, but the instant that light comes on, I'm awake. Like in that same moment, 99% of the time. I have a backup alarm in case it doesn't, but usually that light comes on, I'm awake immediately and not terribly afraid. The one weird aspect is that waking up to a light very, very efficiently synchronizes your sleep cycle to wake up at that time. So I don't even necessarily need the light to wake up at somewhere between 5 o'clock and 6 o'clock. The problem being the most annoying is when I wake up at 5:20, when I'm supposed to wake up at 5:41, and it's like, oh, well, I can either go back to sleep and wake up to the light, or I can wake up now and be super tired because I missed out on 30 minutes of sleep. This other thing is actually my cell phone charger. Because, you could connect it the other way, but I wanted power for my cell phone when I'm sleeping. There are deficits to this device. Two big ones. The first being, this timer is very hard to accurately project. It's not like a clock where you can just say, oh, it is this time. You're always a little off. So if the power goes out or you unplug it, it doesn't quite work. Right now it actually is plugged in. You can see that's what the light looks like when it turns on. Wakes you up very quickly. It's very bright. The other problem being the click of death. These timers have a little electromechanical mechanism in them that is very quiet, and you wouldn't hear it normally, but I hear it. When you're asleep, you're hypervigilant. At least I'm hypervigilant. I'm aware of everything when I'm asleep, to the point where people can have conversations with me when I'm asleep. If you say my name when I'm asleep, hey, you dirty schmuck, slap! I wake up straight away. That click will wake me up even when the machine is not running. And, on like a Saturday or Sunday or Wednesday or Thursday, I mean, how much of a job do I actually have? When I'm trying to sleep, I have to unplug the bulb. And then it still runs, it still clicks, and it still wakes me up, although not with the light. That's kind of the third problem, is that sometimes I forget to take this out, and I end up with a light turning on at like 5:41 in the morning when I'm trying to sleep. And the reason I could grab this with my hand is because despite appearances, this is an LED bulb. Those are not filaments, but LED chains. Turn that off or else I'm going to stick my finger in there and get the dead. It won't actually kill you, but it'll hurt a lot. And may kill you if you're standing in water, which I probably am. So why am I here? Well, that's a question I ask every single day, and I never really get an answer. Because I don't especially care about the answer. Why is this here, though? Because I'm going to rebuild it. I'm going to build a better version. An improved version 2 that is settable, timeable, easy to use, easy to turn on, easy to turn off, and doesn't make a death click. Now, how am I going to do that? I have no idea. Right, so starting. How are we going to start the process of building this thing? First, a clock. This is a small, ordinary alarm clock. Sharp brand. Bought it at Walmart for like $8. Kind of expensive, but not nearly as expensive as most. It has a standard sonic alarm. In fact, it has two. I'm going to set alarm number 1 right now. And we're going to see what it sounds like. The alarm in question is actually set for 7:15, which is not the real time. Don't know what the real time is, don't know what day it is even. So I'm going to go do something else while I wait for that to happen. You hear that? That's what I'm trying to avoid. I would like to build a system into this that allows this clock, rather than make that sound, to turn on this lamp. That way, instead of that annoying sound, I can get a nice, calming glow. So your first step is going to be to get it open. Now it says clearly on the bottom, warning, shock hazard, do not open. But the other half is avis risque de choc électrocuté, ne pas ouvrir. And I think ouvrir is French for forget. So I'm going to forget everything that's on that and open it anyway. The process requires a relatively thin screwdriver. You're going to want to keep the screws. Well, you may not want to keep the screws, I don't know you. That you know of. So, let's see. The inside of the clock looks like this. The faceplate on this comes off first, which is kind of weird. Usually it would be the backing plate. And then the underside also comes off, which makes this a little more challenging. So that's very fragile. I don't want to pull on that. They're not making this easy on me. Well, you know how I said don't have it plugged in because that would be ludicrously dangerous? This part requires it to be plugged in and open. So try not to die. That's a warning to myself, more so than to you. You guys are probably competent. I am not. So I've got my voltmeter here. And what I need to know is what voltage the transformer inside is actually producing, because that's how it works. This is 120 volts, the killer voltage, but the clock obviously doesn't run on 120 volts AC. It has a tiny transformer in it. That's the shocky part. If I flip it over, you can see it's that red thing. It converts this power into the power the clock uses. I need to see what the internal supply actually is. So that connects right here onto the front. So I stick this, and then I stick this. 6.23 volts. So it's about a 6-volt transformer, which would be 1/10 divided, it's a 1/20th transformer. So that is converting the electricity from the wall into 6 volts, which is a usable amount of voltage, I think, for what I want to do. And that is control a relay. And what exactly does that mean? Well, I'll show you. This is a relay, a very large relay. So it looks like an ice cube with a bunch of circuits and electronics in it, but it's actually comparatively simple as to what it is. A relay is an electronic switch. A switch is just a device that connects two metal things together to produce a contact, which allows electric current to flow. Off, on, off, on, off, on, out, out. Why is my finger numb? Too much voltage, I think. Whereas a switch is something you would poke with your finger, a relay does it with a tiny electromagnetic coil. So you can see in there, that green thing is a coil. What it does is, when energized by electricity, squeezes the whole system together, causing an electric contact. This one had been used previously in a similar control system, I think, based on what's soldered to it. I don't know what this was actually for. I just found it in my spare electronics bin. So this relay is not exactly unique, but there's a lot of different types of switches, right? Thousands, hundreds. A switch can be anything. This is a switch, those are switches, that's a switch. A switch is just something that makes one or more electric contacts. This relay is kind of unique, not exactly unique, because this is a really common layout. Now look how many pins there are. That's a lot more than just 2 for a switch, right? Because it's not that kind of switch. This is called a double pull, double throw relay, which is a complicated term, which basically says there's one electrode, which here is this. These are large wires for controlling AC current, which, when the coil activates, it moves the connection from here to here. Ding, 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 ding. So it moves the connection between the two. So right now, the relay is open on this side, so there's no electric current here. This is not connected. When it connects, it does connect there. But it is connected to this one, so electricity would flow freely through there. And it's a clone of that switch on the other side, which sounds really complicated, I'm sure, unless you've seen like the layout of these. The point being that if I were to connect these to that circuit for the light right now, the light would be off because the relay is not connected. The switch is open. You can probably even see it in there. Avoid shocking my armpit. The switch is this sort of black thing with a lever and some copper pieces on it. That is open. When the relay activates, it closes, so the light will be off until electricity is applied here. When electricity is applied here and the coil activates, it turns on. So that's basically what I need to do. Right there you can see that's the piezoelectric speaker. The piezoelectric speaker, I'm guessing, receives a pulse to generate its sound of about 6 volts. Right? I mean, that's how it works. The piezoelectric speaker, it receives the voltage and it vibrates. I mean, it receives a pulse of voltage and it vibrates. That's what makes the sound, right? So all I need to do is disconnect the speaker and instead connect it to the relay. Theoretically, there is some math involved in that. Oh, look at that. This is even, I thought this was a 5-volt relay. This is, in fact, a 6-volt AC relay. 6 volts AC. Why is there an AC relay? That doesn't make any. Because the coil is ambiguous. It doesn't care what it receives. It's capable of controlling 1/6 horsepower at 120 max. So, I don't understand the rest of this. I'm not an electrical engineer. The point being, I'm going to take the speaker out and connect it to the relay. Okay, so I've built, at the very least, a portable outlet. It's not actually going to be portable when it's done. But partially the reason why I actually covered this one is because I actually intend to use this as a piece of consumer electronics, and I don't want to go sticking my hand in electric lines whenever I try to wake up to turn the off switch off. That's the output where the AC line will get connected, and as you can kind of see, the relay has been connected in a way that I had to come up with a configuration for it. So this is a sort of schematic diagram of a relay, which may be initially difficult to comprehend if you haven't seen them before, or if you have seen them before, I don't know how to draw them right. So the relay is a switch here, with a normally closed, and C, a normally open, and O. So a relay is normally like that. When you power up the coil, it goes click, and it goes over here. Now, in this case, the relay has two of these. So there's another one that'll actually turn on the lamp. This is the other one that's not being used for that application. What I have set up for it is so that that pole that's always connected to this powers the coil itself. You say, that sounds a little odd, but here's what it does. The alarm signal is not a consistent signal. It's a... When the alarm signal enters, it travels through the relay, through its needle, and through the coil. This is the on-off switch. So that would be closed. It activates it. The needle goes click over to here, disconnecting it from its source. Now, if that was not connected to anything, what that causes is that's a paradox configuration in a relay. It causes it to go and it makes a which is very bad for the relay. But in this case, it switches it over to this, which is just positive from the transformer. That's why, I don't know if I mentioned it, but I have drilled holes and connected wires into the clock, so I have the AC output, main power, and also the controls for the what were formerly connected to the buzzer. So it'll still work as a clock. It does turn on. Those are just controls that'll go here. So when this switches, it's now just pulling across itself to power itself, and it stays on. That's called a latching mechanism in a relay. You can either have the paradox or the latching, depending on how you configure it, but that means that once it's connected, it stays on. The only way to turn it off is this switch, which I mentioned earlier, is down at the bottom. That's the off switch. When I click that off, the whole thing decharges and it goes back to the normal conformation. So if you turn off the alarm and turn off the system, everything's turned off and it's waiting to go again. In addition, and completely unrelated, I've reached the point where I need to obtain a power cord for this, because this is going to plug into the wall. Now, you can make those, you can buy those. I prefer to salvage, to be green about it. So what I have is this is a paper shredder. It is my paper shredder that I formerly used to shred documents. The problem being that the cutting blades have gummed up. They got too much paper in them. I tried to put too much through. They stuck. Now those are very sharp. Interestingly and slightly comically though, even in its current state, it does work in that the engine or the motor does turn on. Let's see, I need something non-conductive, like a pencil. Paper shredders are actually built real smart, so you can't tamper. They have this snap action switch, which needs to be on when it's closed. So it does function if you defy that and are willing to work with electrified stuff. The reason the shredder doesn't shred is because I've disconnected the gears that would normally power it. So you can sort of... That's a pretty good motor and it still works. So what I'm going to do with this is sever just the power cable, but be sure I know where the power cable is, because I feel like I could use that for something. I don't know what yet. It's a AC motor with a considerable speed and relatively high torque, so if you have an idea of what in the world I could use that for, please let me know in the comments. Otherwise, I'm going to disconnect that cord and build it into this system so that it will be complete. That'll have to sit probably not like that. And I will finish the last steps of assembling this into a sane and reasonable system so that the next stage I can start connecting it to the clock and doing the testing. Now you may notice, oh, why is not like every YouTuber he just going through it as he's doing it? The answer is you'd find that terribly boring. It's mostly just me sitting here for hours on end in this very cold basement. It's probably about 40 degrees down here, which I live in New York. I'm used to that. That's like the temperature your house is in the winter, which is why it's called le shiver if you're French. Oh, this circuit. This circuit took me a lot longer to make than I thought it would. I've been down here for a long time. I could set off Geiger counters with the amount of radon in my lungs right now, the amount of coffee in my spleen. There's flies coming from places I don't understand. Everything smells funny, and I might have burned my fingers on the soldering iron because, you know, you don't hold it like you hold it with this part, not the. Regardless of that, that's the circuit, so to speak. It looks like a table because the actual circuitry is located in there and held together by hot glue because I don't have printed circuit boards. There's some of the hot glue now. But it sure looks nice from the front now, doesn't it? The problem being that all of the assumptions I made to make this circuit originally didn't work. Mainly being the little positive negative that's still connected out of the back of there that controls the buzzer or speaker. It's a tiny piezoelectric speaker in the thing. Does not nearly have enough power to turn on the relay. So you can't, it won't turn on. I thought, oh, this whole circuit's ruined. What am I going to do? Well, I'll try to build a transistor amplifier. But that didn't work. But eventually I came up with a thing. I'm sure that's normal. This is the schematic that this thing runs off of. And if you understand schematics, you understand that this is basically running off pure belief. So the signal comes in through an optocoupler, because I found some in my kitchen cabinet where I keep glasses. That's basically a tiny chip that has an LED and some phototransistors. So when the signal that would normally power that microphone or that little speaker comes in, it makes an entire. I can connect it to a light and make a light flash. It's just a tiny little light. It's flashing inside this chip, so you can't even see it. It powers up this, which then goes into this array of transistors, which is a Darlington. Say, why do I need a Darlington? It's because this transistor wasn't powerful enough to turn on the relay. It would just make it sort of jump. Then you may wonder, why are there two LEDs in series in a 57 ohm resistor? The 57 ohm resistor, because that's the only resistor I could find that was not like 2 million mega ohms, and two LEDs, one of which has to be white. Because if you just have this freely connected, it gets interference from the internal circuitry in the clock, and it makes the whole thing hum, and the relay just hums all the time. This keeps it's basically a gate, it's like a weird Zener diode, but backward. It keeps it from activating until it's really activated. So, you may also note I'm using an NPN and a PNP, because that's what I had. That's one of those little guys. That's a bigger power transistor. So that activates this. It activates the relay, which turns on my big diode system, the light itself. Which, interesting to that, when you're wiring outlets, they wire on opposite sides, not the same side. Blew a circuit breaker doing that. It also has this, so that's the latching mechanism I talked about before, so that it latches back to power through the transistor that normally activates it to just keep this whole circuit running. Needs that resistor, found that out the hard way, lots of smoke. And at the very bottom is a switch that allows me to turn the whole system off. And now, when I tried it before, the system did in fact work some of the time. Sometimes it wouldn't, and it would fail for weird and unknown reasons. So I put a lot of hot glue in there, to hot glue the working into it. I also covered, underneath that is the voltage that will kill you if you touch it. That's part of a milk jug, so my fingers don't touch it. This is the control switch that actually engages the system. It's on the diagram. So, part of that is that there's not an internal supply. The thing runs on batteries, which are back there. I can pull them out and they, 6 volts. It's fine. It's only ever going to be on for like less than a minute a day. So I don't think those will run down. They're just to power the relay, which is only like 100 ohms. It's not huge. Which, interestingly, the relay survived shorting itself through wall voltage and shutting off my breaker. Didn't think it did, but somehow it did. Means I have good breakers. Also, I couldn't find the breaker, so I just flipped a bunch. So hopefully everything's still working. I don't know. I don't care. So it has two plugs. One plug powers the light. That one's a little moldy. One plug powers the clock. It's apparently important to turn the clock on first. So right now the clock, don't shock myself, don't shock myself, don't shock myself, should be reading. So I'm going to turn on. That means the system is now armed inside the relay and everything. But I'm also going to make an adjustment to the clock to basically say, this is how I've been testing it. I've reset the alarm to 12:01. It says it's 12 because that's the time that it started. And you get the longest minute of your life waiting for this thing to test. I'd look at that clock while I was doing work on a powered circuit and be like, oh, it's been 20 minutes. Turn it on for a test, it'll be like 7 hours before that minute finishes up. And there it goes. The light activates, so the alarm circuit is actually still firing. It's firing into these LEDs on the side, which if you were to look super close, you can see the white one is kind of on. It doesn't do anything though because it's latched through the smaller of the two transistors, which will heat up over time. Just with that large 15 kilo ohm resistor, it doesn't matter too much. I needed the two because the gain was not originally high, as I explained before. So that light will stay on, as long as it's connected. I can turn the alarm, it's a little complicated. I can turn the alarm off there. The alarm is now not firing, but the circuit's powering itself. It's engaged the relay and latched it. In order to turn the light off, I need to go to this little switch and shut it off. And that means that the light is now off. I'd have to reset both in order to prime it again. Although technically speaking, I can just flip that and the circuit should just be stable and it won't turn on, it won't turn off, it won't do anything. Nothing's connected. The transistors have basically infinite resistance, so there's not even electricity conducting through it. I just usually try to turn my own creations off when I'm not using them to avoid exploding. So basically to set your alarm you just have to hit two switches, which is kind of absurd, but it does give an advantage over this in that I can choose the exact time I want it to turn on. I also get a second alarm clock in addition to my other alarm clock, which I've had for a long time. And that glosses over what was a lot of work, confusion, and eventual compromise. I could probably replace these batteries with a third plug if I wanted to, but I don't want to right now. I've been breathing solder smoke for like 2 days. I can't even tell where I am anymore, but it does work. It's So to summarize what I've created is I've connected the wires of an alarm clock, the tiny thing that would normally control a speaker. I don't like waking up to loud sounds. Even though this one, actually, I feel bad because it has a very nice speaker. It goes beep, 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 which you already saw. I wasn't here for that part. Instead of sound, it's rigged to power light, in that powers a tiny light. That tiny light powers a tiny transistor, which activates another transistor, which activates another transistor, which activates a relay, which then connects this light to power to produce light, which will wake me up in the morning, hopefully, because that one I would have to reset completely. So I can give it a try this morning and hopefully not catch on fire. Well, I'm not too hugely confident that this thing can last an entire night all on its lonesome, but at least it exists. So I consider that a success to a degree, and we'll know once we know if it catches on fire, but it's a thing. Extra?